Automation isn't blocked the way most people think. At scale, websites rarely shut bots down instantly. Instead, they observe, score, and adapt. Requests go through, pages load, data appears to flow. But behind the scenes, signals are being collected. Behavior, timing, browser entropy, all quietly building a picture of intent. That's why automation usually doesn't fail loudly, it degrades. Access becomes inconsistent, responses change, data quality drops, and most teams only notice the problem long after it has already shaped their results. You're on the Proxy-Seller channel. I'm Mark, and today we're breaking down how websites detect automation in 2026. We'll look at why bot detection is no longer about blocking traffic, how modern sites identify automated behavior over time, and what this means for crawling, data collection, and infrastructure at scale. To understand how automation is detected, we need to start with one simple fact. Detection is no longer optional for large platforms, not because bots are new, but because automation now represents a significant share of global web traffic across e-commerce, media, SaaS, and AI-driven data use. This shift has forced websites to move beyond simple rules and towards probabilistic, behavior-based detection systems. And that's where the real story begins. A few years ago, automation detection was treated as an edge case. Most websites relied on simple defenses, IP reputation, rate limits, basic rules. That approach worked when automated traffic was small, predictable, and easy to separate from real users. But that model no longer holds. A significant portion of web traffic today is automated across e-commerce, media, SaaS, and data-driven platforms. As automation scaled, especially with AI-driven scraping and competitive intelligence, basic defenses stopped being effective. What happened next is important. Instead of blocking automation outright, websites shifted strategy. A growing share of sites moved to partial protection models, systems that observe behavior, apply risk scoring, and selectively degrade access rather than hard block traffic. In practice, this means automation often still receives responses but with lower quality, higher friction, or delayed access. The result is a structural change in how detection works. Modern detection focuses on small, high-entropy parts of browser behavior, not on volume or speed. Only a very small percentage of functions, often roughly 1 or 2%, carry the signals that matter most. But those signals are enough to reliably distinguish automated behavior over time. This shift changes outcomes dramatically. Detection accuracy at the function and script level now reaches very high levels. It can approach 99% in controlled lab-style evaluations, even when automation avoids obvious red flags. The key difference is that detection is no longer instantaneous. It's probabilistic and cumulative. Websites don't ask, "Is this request a bot?" They ask, "Does this behavior remain consistent with a human over time?" That's why automation today rarely fails immediately. It passes initial checks, accumulates subtle anomalies, and gradually loses reliability. This is no longer just a security problem, it's an infrastructure reality. To really understand how automation is detected today, it helps to borrow a mindset from site reliability engineering. In SRE, system health is never defined by a single metric. Google's SRE framework describes 4 golden signals: latency, traffic, errors, and saturation. But even those are only starting points. Experienced engineers know that averages hide failures, and that real problems often live in the tail of the system, not in the mean. Websites apply the same logic to automation detection. A crawler can stay within rate limits, it can return HTTP 200 responses, it can generate steady traffic and appear healthy in dashboards, and still be flagged as non-human. That's because availability is not correctness, and a successful HTTP response does not mean the data is usable or trusted. Modern detection systems don't detection. That's because availability is not correctness, and a successful HTTP response does not mean the data is usable or trusted. Modern detection systems don't ask whether requests are flowing, they ask whether behavior remains consistent with real users under changing conditions. From an engineering perspective, crawling pipelines behave like distributed production systems, not batch jobs. Each request interacts with external services, dynamic content, timing constraints, and browser execution paths. Even small deviations at the 1 or 2% level can accumulate across a session and become statistically meaningful. This is why monitoring alone fails. Monitoring tells you whether a system is up. Observability explains why the system behaves the way it does. Without observability at the request and behavior level, automation detection looks random. In reality, it's the result of many small signals correlating over time, long before a hard block ever occurs. And that distinction changes how crawling infrastructure needs to be built and debugged. So, what do websites actually measure when they detect automation? The key shift in recent years is that detection moved not away from network signals but beyond them, toward browser-level entropy and behavioral consistency. Academic research analyzing around 100,000 websites and hundreds of millions of JavaScript executions shows that detection logic focuses on a very small part of browser behavior. A very small fraction, often around 1 to 2%, interact with high-entropy APIs, such as canvas rendering, audio processing, WebGL, device characteristics, and execution timing. These signals matter because they're difficult to fake consistently. In controlled evaluations, models based on function-level browser behavior reach very high accuracy, close to 99%, with recall in the mid-80% range, even when automation avoids obvious red flags. Detection isn't based on single calls, but on patterns that emerge over time. Fingerprinting, however, is only part of the picture. Research also shows that a significant portion of detection logic activates only after user interaction. Scrolling, mouse movement, navigation depth, or timing variance. Automated crawlers often miss these triggers, which explains why automation seems to work at first and then gradually loses reliability. That's the pattern most teams experience. Requests succeed, responses look normal, but as behavior accumulates, entropy mismatches appear, and trust quietly erodes. Modern detection isn't about speed or volume, it's about behavioral consistency under observation. One of the most confusing things for teams is that automation works and then suddenly doesn't. That's because modern detection systems aren't binary. They don't judge a single request. They evaluate behavior across a session. Detection is based on accumulated deviations, not instant violations. A crawler may look acceptable at first, but as requests add up, small inconsistencies in timing, execution paths, or browser behavior start to stand out. Even minor anomalies, around 1 to 2%, can become meaningful when repeated over time. Instead of blocking automation immediately, websites usually degrade access. Requests still return HTTP 200, but responses change. Structured data turns into HTML, fields go missing, delays increase. From the crawler's point of view, nothing breaks, yet data quality steadily declines. That's why dashboards stay green, pipelines run, volumes look normal, but trust is gone. Automation doesn't fail because it's detected once, it fails because trust is slowly withdrawn, and by the time teams notice, the cause is already invisible. The takeaway is simple. Automation detection is no longer primarily a network problem. It's a data infrastructure problem. Rotating IPs or tweaking headers doesn't solve it, because websites don't rely on a single signal. They correlate browser entropy, behavior, and timing over time. If proxies are treated as a basic network utility, this process stays invisible. That's why proxies have to be observable. When request-level behavior is visible, timing, retries, response types, and degradation patterns, teams can see where trust is lost, not just that it's lost. Crawling stops being trial and error and becomes something you can reason about and debug. This is the approach we take at Proxy-Seller. We build proxy infrastructure as part of the data stack, designed for large-scale crawling, analytics, and AI workloads, where stability, transparency, and control matter. Our enterprise plans focus on observability, predictability, and responsible data access at scale. If this was useful, subscribe to the Proxy-Seller channel. Leave a like and follow for more insights on building production-ready data infrastructure. And I'll see you in the next video.